Hi everyone, we're going to talk about topic 1.1, structure of water and hydrogen bonding. And so water has some unique properties that make life on Earth possible. So here's a picture of the Clark County wetlands that I took. If you haven't been there, it's a cool place to check out. You should try and go sometime. Alright, so let's talk about water and hydrogen bonding. If you haven't had chemistry, that's okay. If you forget or you don't remember, that's okay as well. But oxygen is in the upper right-hand corner of the periodic table. And because oxygen is in the top right corner of the periodic table, we know that it has a higher electronegativity than hydrogen, which is in the top left. So due to those differences in electronegativity, which is just the ability to attract electrons, oxygen is actually going to kind of be greedy and grab those electrons towards itself. And so when hydrogen and oxygen make a bond and they're sharing electrons or making a covalent bond, they actually end up making a polar covalent bond. And so that just means that the charges are not shared equally, and one is slightly negative and the other one is slightly positive. So since oxygen is pulling those electrons towards it, it has the slightly negative charge. If you remember, electrons have a negative charge. And then the hydrogen is going to have a slightly positive charge. Alright, so what does that look like in a water molecule? You can see this little symbol here. This is called delta. Delta is from the Greek letter delta, and it means partial. So we have a partial positive charge on the hydrogen, and we have a partial negative charge on the oxygen. And that is very important with binding of water to other water molecules and to other things. Alright, so they have a different electronegativity, and because of that, when you get two water molecules close together, the oxygen on one is going to attract the hydrogen on another water molecule. And this results in something we call a hydrogen bond. So the hydrogen bond is a weak form of bond, and it's denoted by these little dashes or dots. That just shows that it's a weak bond. So in between different water molecules, we have these intermolecular charges. If you think of an interstate, it's a road that goes in between states. So these intermolecular charges are between molecules, INTER. And then within the molecule, we have intra, INTRA. Intramolecular charges are within a molecule. So these ones are strong. These are polar covalent bonds, and they're noted by a solid line. Okay, so these are strong charges, these are weak charges, and these are important. Alright, so because of water's ability to form hydrogen bonds, water has some pretty unique properties. So we're going to talk about some of those. Cohesive behavior, ability to moderate temperature, and they can keep temperature stable in locations that are near large bodies of water, like a beach. Water expands upon freezing, and it actually takes up a greater volume. Frozen water takes up a greater volume than liquid water molecules, and this allows ice to float on water. And then water is a versatile solvent. It's sometimes called the universal solvent. It doesn't dissolve everything, but it dissolves a lot of polar molecules and like ionic molecules and charged particles. Alright, so cohesion of water molecules. Co means together. And so this is water molecules sticking together to other water molecules. And this results in something that's called water's high surface tension. So let's look at a picture here. Because of that high surface tension, it actually creates like a skin, like a layer on the top. And anything light will just kind of sit on the top until those hydrogen bonds are broken. So you could try this at home with a glass of water, and you can sprinkle some pepper across the top, and the pepper will stay on top until you break those hydrogen bonds. The way that you could do that is you can then add a drop of soap, and it's pretty cool. Once you add the drop of soap, then the pepper floats down to the bottom, and they won't float anymore. It's a pretty cool little project you can do at home. All right, water is also adhesive. So ad means different. So that means that it is going to stick to, let's see, different things that are also polar or charged. Okay, so this is important with plants especially. It results in something that we call the capillary action. So let's take a picture of capillary action. And if you take a cross section right here of this little tree, and you're going to see some tubes here. These are called xylem. And inside the xylem, there are some polar molecules on the side. And so they will actually form a hydrogen bond with the water molecules. So the water molecules are sticking to themselves, but they're also sticking to polar molecules in the xylem. And that helps water to move up the trunk, up the branches into the leaves, and gets the water through the tree. There's also something else, transpiration, which we'll talk about later, that helps to pull the water up through the tree. But that's the biggest driving force. But this cohesion and adhesion of water definitely helps out. All right, moderation of temperature by water. So because water can form hydrogen bonds, it has this great ability to release or absorb large amounts of heat without very much change in its own temperature. So locations in the same latitude can have different temperatures, even though they're getting the same amount of heat energy from the sun. So let's take an example here. We have Los Angeles, we have Riverside, we have Palm Springs. They're almost about the same latitude, but they have different temperatures. So for this day, the high temperature in Los Angeles was 75, whereas Riverside was 96 and Palm Springs was 106. I used to live in LA until I was 11, so you can imagine how I thought I was going to melt the first year we moved to Las Vegas. I was not used to those high temperatures, but I'm good with it now. All right, so water is really cool in helping to regulate temperature. Water has a high specific heat, and so specific heat is sometimes referred to as heat capacity, and it's the amount of energy required to raise the temperature of 1 gram of the substance 1 degree Celsius. So water has a relatively high specific heat. That is 1 calorie per gram degree Celsius. And so due to that, it takes a lot of energy to turn it from its liquid to its gaseous form. So this allows something like sweat to be really productive in helping to cool down our body. So what happens is your body puts some water on the surface of your skin, and it needs some heat to evaporate that liquid into the gaseous form. It actually takes the heat from our body, and it uses that heat to help it to evaporate. And so it's a pretty effective cooling mechanism. All right, water expands upon freezing. Most things don't do that. When they go from their liquid to a solid form, they usually condense. Well, water is amazing, and it is opposite. It does the opposite thing. So when water forms hydrogen bonds when freezing, let's see. Okay, it wants to maintain those hydrogen bonds, and so it kind of spreads them out a little bit, and actually takes up more space in its solid form than it does in its liquid form, and that gives it a less dense form. So we know that things that are less dense than water float on top of water. So this makes the less dense frozen water float, which is really cool. So why is that important? Well, things like this little shrimpy who lives in the pond, this ice on top floating is actually protecting the rest of the pond from freezing. So here we see some water, and it has some hydrogen bonds, and it's moving around. They're breaking and reforming all the time. But in the ice, they're very stable, and it allows it to float on top. What would happen if it didn't do that? It would sink to the bottom, and then the top layer would freeze again and sink to the bottom, and eventually the whole pond would freeze, and this little guy would die. So water is cool. Frozen water, even more cool. All right, water is a solvent. I don't know if you've heard the term like dissolves like. So it's a polar molecule. So it's a great solvent for other polar and charged particles. So take, for instance, this sodium chloride, and let's see. Okay, so the yellow is the sodium, the green is the chloride. You see this positive charge on the sodium is attracted to the negative oxygen, the partial negative charge on the oxygen, and then the partial positive on the hydrogen is attracted to the chloride ion. And it allows for water to be an excellent solvent for ionic compounds like salts, which are really important in most living systems, and for other polar molecules like sugars and amino acids. All right, so let's review. What did we talk about? Water is a polar molecule. Why is that? Because it has polar covalent bonds. Why does it have polar covalent bonds? Because oxygen has a higher electronegativity, or ability to attract electrons, than hydrogen does. Because water is polar, it forms these hydrogen bonds, and these hydrogen bonds allow water to have cohesion and adhesion, a high specific heat or heat capacity, and the ability of solid water ice to float on liquid water. And these properties give water its high surface tension, its ability to stabilize temperature, its ability for sweat to bring down our body temperature so we don't get heat stroke every time there's a hot day, and it allows water to be a really good solvent for polar and charged molecules. All right, guys, I hope that made some sense, and have a great day. I will see you next time. All right, bye.